Check if array is sorted. Validate every adjacent pair. Check whether the array is sorted in non-decreasing order. Consider the array 1, 2, 2, 4, 5. The array is sorted. Every value must be greater than or equal to the value immediately before it. Equal adjacent values are valid. One decreasing pair is enough to return false immediately. Start with the second value and compare each adjacent pair for non-decreasing order. The input array is 1, 2, 2, 4, 5. 1 is less than 2, so this pair is ordered correctly. This pair passes, so continue to the next adjacent pair. Both values are 2. Equal neighbors are allowed in non-decreasing order. This pair passes, so continue to the next adjacent pair. 2 is less than 4, so this pair is ordered correctly. This pair passes, so continue to the next adjacent pair. 4 is less than 5, so this pair is ordered correctly. This pair passes, so continue to the next adjacent pair. Every adjacent pair is in non-decreasing order, including equal neighboring values. No decreasing pair exists, so return true. Check if array is sorted comes down to 3 ideas. Start from the second value. Compare each value with the one before it. One decreasing pair proves the array is not sorted. O of n time and O, 1, extra space. Begin at index 1 because each check compares the current value with the value immediately before it. Non-decreasing order allows the current value to equal or exceed the previous value. If the previous value is greater than the current value, the sorted condition is violated. One decreasing pair is sufficient proof, so stop the scan and return false. If every adjacent pair passes, return true. Single-element arrays reach this result without any comparison. The scan takes O of n time and O, 1 extra space, with early exit on failure.